with the AD part. I've got plenty of the HD part. Yeah. I can type with focus if I need to. So we're testing bike brakes. Which variable are we testing? Once again, it's mu, and it's actually two mu's if you want to be particular. There's actually two different mu's we're testing. What's mu1 going to be?
Before.
Sure, and I'm going to call that the cantilever brake stopping distance. Right? This is going to be the average cantilever brake stopping distance. And mu2 is going to be the average V brake stopping distance. I think cantilever brakes are called U brakes, which makes it even worse because they're shaped like a V and V brakes are shaped like a U.
Maybe it's about the pulley system.
Well, I blame the Europeans. If you look at road bike cantilever brakes are actually U-shaped. There's a different shape to them. So there's a lot of bike history that doesn't make any sense. All right. Now let's just start building our hypothesis test. We're going to have to stop pretty quickly when we get to the test statistic, because that's where really interesting stuff happens, and I want to make sure you understand what's happening when we run things through technology. Go ahead, Stacey. Oh, absolutely. We're going to test them both at the same time. Why we're going to test them both at the same time versus not testing mu1 by itself and mu2 by itself? Because you lowered your confidence. I got a solution for that. I'll just increase my confidence level so that when I run it twice, it knocks it down to 95%. What have I just done? If I increase my confidence, what have I also increased? Say that again. Which one? Which one have I just increased the likelihood of? Type 2. No, I've decreased. This is good. I have a quiz for next week for you guys on error analysis. I made a spreadsheet that one you guys saw in class. I'm going to upload that with the quiz and let you mess around with this. If you increase confidence, that's essentially pushing out that little fence post on the curve. Does that make sense? Pushing out the fence post on the curve, which makes the little tail end small. That's your type 1 error. So if you increase confidence, your type 1 error is going to go down. But do you remember, and it's okay if you say no, this is why I'm making the quiz for next week. If type 1 error goes down, type 2 error has to go up. And that's a function of mathematics. So that's what I don't want to do. So Stacey, long-winded answer to your question, yes, one template. One template because I want to keep whatever our confidence is. But I do want to look at the errors as well. Yes? Let's look at the errors on this. So I think we have to identify, oh no, we have to get hypotheses first. So H0, HA. What's my claim? Or what's our claim? You guys actually made the claim. I put the data up in front of you. Renee?
That mu1 is greater than mu2.
I wholeheartedly agree with that. Everybody okay with that? Yep. In words, the average stopping distance of the cantilevers is greater than the average stopping distance of the V-brakes. That's what you guys, or say it a different way, the V-brakes are less than the cantilevers. Either, Laura, what's on your mind? Please.
What are we testing for?
We're trying to see, I phrased a very English, non-statistical question. Are the V-brakes better? Better means it takes less distance to stop with them. So if the cantilevers are worse, they're going to take more distance to stop than the V-brakes.
So then
That's just symbols.
So then if U2 is less, does that really mean that U1 could be greater than or equal to?
Well, this is a good question. Greater than versus greater than or equal to. I like to keep equality out of here, and the only reason I do that is convention. Nobody else puts it in there. These are continuous curves. Deanne, thank you for that, actually. These are continuous curves. I bet you some of you guys have been thinking about that. Why does the equal sign always seem to go in the top? Why is it never in the bottom? Maybe you haven't been thinking about it. That's okay, too. So the reason is it doesn't matter where it goes. This is continuous data. Continuous data versus discrete data. Continuous data, you can never actually land anywhere exactly because the likelihood of landing exactly somewhere on a number line is essentially 0. Discrete data, of course you can. As a matter of fact, I screwed that up in a 105 simulation and I just caught it. I'm like, why are these numbers off by 8%? Because I left an equal sign in instead of pulling it out. And that made a 4% difference on both sides, which agreed perfectly with the binomial. I'm like, no, there you go, we'll do stuff at 9 o'clock at night. But with the continuous data, the chance of it actually landing here or
Same as
here, it's essentially 0. So it doesn't matter if you put an equal sign or not. You can just put the greater than sign. We have to deal with it in terms of greater thans. Is that fair? Cool. So what we want to do is we want to see, does our data land out here in the 5%? Which would mean the cantilevers are worse. Statistically significantly worse. Then we can analyze, we can hyperanalyze practical significance if we want to. Fair enough? Good. So, what's the null? If you want to put the null in? All but that, right? Good, good. How many of you guys are using the is not greater than? Anybody still using that? Yeah, good. I mean, here's your choices. Either of these will do. mu1's less than or equal to mu2, that's totally fine. mu1 is equal to mu2, that's conventional. And I've alerted Emily when she starts grading these. Actually, I might be grading all your quizzes from now on out because she's going to be in Chile for a couple weeks. But I've told her expect up to 3 different things up here. This is the opposite of this, obviously. This is the conventional opposite of this in publications you'll see. And then you guys very strictly have been just going, well, it's not greater than mu2. And as a math guy, I love that one. Happy. Your choice. Pick one and go with it. Pick one and go with it. You don't have to put all 3. Just pick whatever one makes the most sense to you and go with that one. Cool? Because if any of these are true, that means we're here. Right? We're still on the curve of the cantilever and the V-brake being the same. This means the cantilevers are worse, which means they're taking more distance to stop. Good? Let's do an error analysis. Let's do an error analysis and then take our 5. Because we're going to need more time to develop this test statistic. That's going to be the interesting part of the whole thing, is making sure we know what the test statistic is. And how to calculate it correctly. Especially due to Stacy's question she asked. It's very, very good. One template? Yes. There's something interesting with that. Okay, type 1 error.
Saying the cantilevers are worse than the V, but they're actually not.
Good! Saying the cantilevers are worse, but they're not. False
Which
positive.
would also be the same thing as saying.
Saying the V-brakes are better when they're not. Sure, you can say that either way you want to. Both of that English-wise says the same thing. Saying that the cantilevers are worse than the V-brakes, or that the V-brakes are better than the cantilevers, when in fact they are not. When in fact they are not. Okay, cool enough? Type 2 would therefore be, yes, saying the cantilevers are not better than the V, or not better, I shouldn't say better. Saying the cantilevers are not worse than the V-brakes. Yeah, sorry. I'm trying to say it both ways and I end up confusing it there. Saying that the cantilevers are not worse than the V-brakes, or conversely, that the V-brakes are not better than the cantilevers, but in fact they are. There is a difference and we missed it. That's the generalized false negative. There's your 2. You guys pick one, tell me which one you think is the worst.
Type.
All I heard was type.
1.
She says type 1! Tell me why!
Because
So you're saying, if I identify the cantilevers, I say, yes, yes, they're worse, but they're actually not. Go ahead.
then, however long it takes you to replace them, you're still going to be fine.
Okay, so in other words, if I get a false positive, I've said the cantilevers are worse, so my brain thinks the V-brakes are better. So that means I've got to now invest money, go buy the brakes, go put the brakes on. And I like that, because depending on how comfortable you are changing brakes on a bike, that can take days, and you might do it wrong. I mean, I'm lucky, I've been working on bikes most of my life, so it's pretty quick. But if you don't know what you're doing, you might create more problems than anything you think you're solving.
And you might tell all your friends to do it too, and then they might get mad because it's all not.
Very, very true. It might perpetuate the myth that V-brakes are. These are good. I'm not saying you can't be right or wrong with the statement here. JC, go.
So if you think that they're better, you might be overconfident
Placebo effect.
when you're riding, and then that could.
That would be a good one.
And now you've swapped your brakes out. You've got the V-brakes on there. You're like, I'm badass.
Yeah.
I'm gonna hit that turn at full speed. Unfortunately, you got errant data in your sample because Max, unknown to me, moved the ruler back 4 feet while I wasn't looking. Sampling error, right? So then you go into a turn at full speed. You're like, I got this. I got at least 4 feet extra. You go in 4 feet further, end up around a tree, separated shoulder, cussing on the ground. Good. So type 1's worse. I mean, I'm hearing some type. I would say type 2's worse. Jamie says type 2. Tell me why.
Because
you think the cantilevers are
Not worse.
not worse, then but they are, then you might be needing to stop really quickly and run into something or get hit by something.
Right! There is a difference, but you missed it, so you don't bother changing the brakes, which might actually cause the accidents you were trying to avoid with the experiment, potentially. Serena, what were you going to say? Go ahead, type 2. The same exact thing. So in other words, if you miss the difference, if you miss the increased, or the decreased, I guess, braking distance, if you miss it in the test, that might be worse because then that might actually cause the very accidents you were trying to avoid by doing the test.
You're going to be overconfident. You think, oh, these brakes work. But
So
they
it's the
don't.
same.
Oh, I got you. Oh, I got you. So we can actually go and get overconfidence both ways. Like, oh my God, all these guys on the online forums were wrong. Believe it or not, now here's the thing. You very often heard, and you've heard me say this too, one of the reasons I love it when you guys work together on stuff, like when you come in and you're checking your answers on projects, I love that. Because as you do that, you're checking each other, and the chance of every single one of you being wrong is essentially 0. The chance of at least one of you having it right and therefore sharing it is essentially 100% at that
So now
point.
what's the chance of you going and the first 4 people you talk to all have different answers?
You guys are the outlier and the anomaly, I'm going to ignore it. You guys are the 14.4 skid, I'm throwing you out. Now the thing is that you got to be careful with online stuff. I read in at least a half a dozen sites, you can't use mini Vs, you can't use mini Vs. You can use mini Vs. Those 6 dudes were wrong. But you can't apply the laws of probability to that because those are self-selected people. They're choosing to post that. The guys that know the V-brakes work probably are just feeling like, these guys are dumbasses. They don't know any better. I mean, that's quite possible. So you can't treat that as a random sample. Is that see what I'm getting at? So you have to be careful trying to apply the laws of probability to non-random data because then it could blow up in your face. Go ahead. Are you sure? What were you going to say? What were you going to say? You were going to say something? I cut you off.
I was saying a smart ass comment that the guys that know the V-brakes work are riding their bikes rather than posting online.
Maybe they're too busy commuting somewhere than posting online, right? I like online threads, don't get me wrong, I love them. I've learned so much from them, and that's why I like giving back with the YouTube videos, putting that out there, letting everybody have whatever's out there, because it's information. The trick is you gotta make sure it's good information. Sometimes you're getting biased, right, it's not a random sample, which means you might be getting this biased, goofy little, oh, this doesn't work, this doesn't work. More on that to come. Let's take 5 right now though, because we're about to get to test. We're about to test our hypotheses. I like the type 1, type 2. I'm with both of you guys, actually.